of Irrigation Engineering on 22nd of April. This is section A and D. At the moment, 17 students are with me. I have put the link on WhatsApp and started the recording also. Let me share the screen. Okay, before we start today's lecture, which is about method of irrigation. So if you have any question from the last lecture, previously we were studying the topic of crop water requirement, how to compute it, and second part was soil, crop and water interaction, and also we have informed you how to calculate the total water required for a group of crops in the field and how to estimate the water required using the concept of duty, using the concept of delta, base period. So any question in this regard? If I get a couple of questions, that will be good. Yes? Anybody? Irtaza Naveed, can I talk to you?
Yes, sir.
Irtaza, how are you?
Alhamdulillah, sir.
Okay, खैरियत से हो? Last time we studied crop water requirement.
Yes, sir.
So can you tell me what do we mean by duty of water?
सर ड्यूटी वो एरिया होता है जो 1 मीटर क्यूब से हम इरिगेट कर सकते हैं ड्यूरिंग द होल बेस पीरियड.
1 meter cube
ऑफ वाटर.
only 1 cubic meter water? Can you correct it? A cubic meter of water. Izan Ahmed Mansoor or Lizan Ahmed Mansoor? Izan.
Yes, sir.
So your name is Lizan?
Lizan Ahmed.
Lizan Ahmed. So can you correct the definition of duty as given by Irtaza? What was the mistake in that? Hopefully you listen it.
Yes, sir.
Irtaza, can you repeat so that he can listen it again? Irtaza, can you repeat?
Sir, I defined duty as the area that can be irrigated by 1 cubic meter of water.
So can you correct it now? No. Okay,
Sir,
Lizan, what is the mistake in his definition? Okay, anybody, raise your hand. Thank you, Lizan and Irtaza, for
okay, sir.
your talk with me. So it is Mr. Muhammad Umar Farooq.
यस सर.
यूनिट डिस्चार्ज हो अगर हमारे पास तो उससे जितना एरिया एक स्पेसिफिक क्रॉप के लिए इरिगेट होगा दैट इज ड्यूटी.
बिल्कुल ठीक है. व्हाट इज द यूनिट डिस्चार्ज इन एसआई यूनिट्स?
1 मीटर क्यूब पर सेकेंड.
1 cubic meter per second or 1 meter cube per second. Irtaza, feel the difference? Irtaza.
Yes, sir.
Feel the difference. He is saying 1 cubic meter per second,
Yes, sir.
and you say 1 cubic meter. Very small difference, but conceptually very wrong.
Yes, sir.
So 1 cubic meter per second is a tank of water, 1 meter by 1 meter by 1 meter. So how much hectare it can irrigate? It can irrigate a few square meter, a few tens of square meter. So you should try to think yourself what you are saying, 1 cubic meter. So if we provide a cubic meter per second of water throughout the base period of the crop, throughout, not for 1 day, not for 2 days, throughout. So then how much area can be irrigated? That is the duty of water. Okay, thanks. Hopefully now everybody understand. Did I inform you what is water allowance? Who will tell me? Ali Usama. Ali Usama. अपना माइक अपने पास करो, आवाज दूर से आ रही है. अली उसामा.
यस
जी,
मोबाइल
कैसे हो
पे हूँ
आप?
इस वजह से.
मोबाइल को अपने
अलहमदुलिल्लाह.
पास करो, मुझे देखने की जरूरत नहीं है. ओके, टेल मी व्हाट इज वाटर अलाउंस, अगर तो मैंने बताया था.
Yes, sir. Sir, water allowance. I think there is quantity of water that can irrigate 100 hectare.
It is a quantity of water for
That can irrigate 100 hectare. I think it's 100 hectare or 100 hectare.
100 hectares. Anybody else? So quantity of water in what units? Usama, Ali Usama?
I think cubic meter or in cubic meter per sir, acre feet can be in acre feet or depth unit in anything.
Usama Shahzade ho tum. So who can correct him? Okay, Ali Usama have started again like it is a
Sir, discharge cube per second.
who is now saying? Who is speaking?
Sir
Danish?
Mohammed Danish. Yes, sir.
Danish is speaking. Okay. Danish, tell me what is water allowance?
Sir, discharge in meter cube per second or Q6 required to irrigate 100 hectares or 1000 acres.
Okay, yes. So specify it separately for separate units. So if we go for Q6, then the discharge, it is not discharge required. So one thing you should keep in mind, it is not the discharge required. It is discharge which is allocated.
Okay, sir.
So discharge or flow allocated for 1000 acre of land. So if discharge is in Q6, discharge in Q6 allocated for 1000 acre of land. So what is the difference between allocation and water required? That is the difference of demand and supply. Maybe they need 5 Q6 for 1000 acre, but if I allocate 3 Q6, then water allowance is 3 Q6. Water allowance is allocation, not the requirement. Sometimes it meets the requirement. Optimum thing is that it should meet the requirement, but we cannot meet the requirement. So we allocate different water allowances at different places. So most of the canals have a fixed water allowance in a certain season, and people are well aware of that. That canal, UCC canal has a water allowance of so much. This BRBD canal has water allowance of so much, and Thal canal has so much. So irrigation people are well aware about it, and it varies between I think 2.5 Q6 for 1000 acre to as high as 12, 13 Q6 in Sindh province. In Punjab, it seldom go above 8, 7, 8 Q6 I think per 1000 acre. So that is okay. That's nice. Hopefully it will be remembered by you. And if somebody asks you during the interviews, during the viva, so you will be able to answer. So now, when we have already started talking, any questions from your side? कोई शेयर करना चाहेगा कुछ? No. Very obedient and quiet class. Okay, next we have to go towards, we have to introduce you about different methods of irrigation which are practiced commonly in this region, in this place. And these methods need to be known to you because they affect the efficiency of the water use. They affect the how better we can utilize the water. So you should be knowing about it. And when you want to calculate the water requirement for a certain area, then method of irrigation is also controlling the water requirement. We have not informed you how do these methods affect the water requirement, and we have told you the methods only because of water application through surface irrigation method. That is one of the irrigation methods, surface irrigation. So those methods, those pan evaporation methods, that lysimeter method, that Blenny-Cradle method was for a common method of irrigation, that was for surface irrigation. If we know that in the area for which we want to calculate the crop water requirement, that is using some other method like sprinkler and drip irrigation method, then the crop coefficient K that we used previously in previous lecture, so that will be reduced to certain extent, that will be reduced. So if somebody want to see the effect of method of irrigation on crop water requirement, then I will say that he should try to calculate Kc, crop coefficient, as given by Food and Agriculture Organization in their report. They call it FAO 56, report number 56. So they have elaborated, they have given a chapter how to calculate the K values for different method of irrigations. So the K value which we put in the previous lecture through tables, those were for surface irrigation method. That is most commonly used. But for other methods, you have to go to the further, you have to see the literature and try to calculate it yourself. So this is a required method of irrigation need to be known for this purpose if you want to calculate the crop water requirement. And it will enhance your knowledge, because when you will be working as an irrigation engineer, then you can ask the people to go to the more water efficient method of irrigation. So then you should be knowing all the methods possible for irrigating the land. So these methods are with respect to application of the water in the field. If somebody asks method of irrigation, maybe at higher scale, at broader scale, not at the field scale, method of irrigation can be divided into some other classes like uh, gravity irrigation method, in which the water is provided to the irrigation field through the gravity. Somebody can say method of irrigation as pumped irrigation method if they lift the water, or they can call it lift irrigation method. So such kind of categories can also be described, gravity irrigation, lift irrigation, but that is at the larger scale, at the whole canal command level. But at the field level, if water is available, how many ways we can apply it. So those are these few ways grouped into 4 categories. The first category is application of water through the surface. Above the surface we supply the water, and usually the gravity gives us the force to provide water to the field and to provide water so water reaches to all places of the field through the force of gravity. And force of gravity comes into action when there is a slope. So when slope is there, so then water will flow and water can reach to the field through the water supply channels, through the water courses, through the small channels or ditches in the field. So surface irrigation method is one of the commonly used method in Punjab, in Pakistan. And the second method, which is separate from it, that is the subsurface irrigation. We supply water not from the surface, but through seepage underneath the groundwater. Water is provided at below the ground level, and then through capillary action, through seepage from the pores of the soil, water reaches to the roots. So we don't see any pondage at the top of the groundwater. So that method is called as subsurface irrigation method. We don't see this method much practiced over here. Special kind of porous soil is required in the upper layer, and then we need something of impermeable layer at 1 meter or 2 meter depth, so that water should not percolate deeper underneath. And we provide water on the sides, and water seep through the pores and reaches to the root zone. So that is subsurface irrigation. It is more water saving method as compared to the surface irrigation method. Two new methods, relatively new methods, sprinkler irrigation method, and sometimes we call them as high efficiency irrigation system, HEIS. Sometimes we call these sprinkler and trickle or drip irrigation method, we call them high efficiency irrigation system. So they primarily they are dependent upon the piped system. We supply water not through the channels but through the plastic or steel, galvanized steel pipes, and then we supply water either from the either from the sprinkler guns or sprinklers from the top of the crop, or in case of the trickle irrigation, we provide water in the form of the droplets of the water. Drop by drop, water is supplied to the roots of the crop. So both of them are considered modern with respect to their life, and both of them are high cost. Initial cost is high, but their application efficiencies are better. What do we mean by application efficiency? Application efficiency is defined as the water used by the crop divided by the water supplied to the crop, and that will be given, this definition is given in slide 34 over here. So two kinds of water efficiencies are mentioned over here. Hopefully my slides are shared. Yes. Slide share hai ke nahi hai?
Yes, sir. Share this.
Yes, sir. Here.
That's good. That's good. Okay, this water application efficiency is ratio of water used by the crop to the water supplied in the field. So if we have supplied, for example, 4 millimeter of the water, and actually crop have utilized 3 millimeter of the water, so the ratio of this will be the application efficiency. There are other efficiencies also which we measure to check the quality of our irrigation system. There are many indexes. These factors are called index or indicator to measure the efficiency. So for example, one of the efficiencies is how much crop we are getting, how much mass of the crop, how much tons or kg of the crops we are getting by application of the unit quantity of water. That is a crop mass produced per unit of the water. So when I have to compare a system of irrigation in Punjab, in Pakistan, and a system of irrigation in Punjab, in India, so this is a good method. How much kg of the wheat they are getting by using a cubic meter of water, how much kg how much kg or tons of wheat they are getting by using a cubic meter of water. And in the previous lecture, when we were telling you about Indus Basin irrigation system, this water use efficiencies was informed to you that in Pakistan, the yield per unit of the water utilization is less. I think we told you for cereals, it is 0.13 tons per cubic meter of the water utilization, while in the neighboring country it was higher than that. So these are used to measure the quantitatively see the efficiency of a system at a place. There are other indicators, tens of indicators are there. How good an irrigation network is working. For example, one indicator I am remembering is delivery performance ratio, DPR they call it. That is for efficiency of a irrigation canal. How much that is the ratio of how much water was allocated to a certain outlet and how much water was actually released to that outlet. For example, there was an outlet which was allocated 1 cubic of water. So if it is getting 1 cubic of water, then we say its delivery performance ratio is 100%. But if it is in a year, it is getting on average 0.75 cubic of the water, we said DPR is 75%. So similar indexes are available, indices are available, indicators are available, parameters are available to calculate the efficiency of system in a variety of ways. So we have to tell you these methods, one thing, and the second thing we have to tell you their performance, which one is better than other one, which one should be used in what condition, what should be the soil type, and what should be the condition of topography. Sometimes topography controls. If it is undulating topography and I don't want to make it plain topography, topography means the elevation of the surface, something like that. If it is very plain, if it has a gentle slope, or if it has steep slopes, so that is represented through topography of the area. These methods have been described by FAO also, and their reference is given at the bottom of this slide. And its PDF is downloadable from this link. So they have mentioned these four groups of the method. Each method can be further divided into the subcategories depending upon small changes within that method. So same distribution or same change of this method of irrigation is described in this slide in the form of a flow chart. So if we can broadly divide the method into four categories, and the surface irrigation method can be further divided into three categories, while sprinkler method can be divided into two categories, and drip irrigation can be further divided depending upon which kind of the drippers they are using it. Within the surface method, the border oblique strip method, check basin method, or furrow method. There is another method of surface irrigation, they call it uncontrolled surface irrigation method. That is one of method not mentioned over here. So within these methods, we can further divide them, whether we are providing this method of water application on a field which is divided based upon contours, based upon the difference of the levels. So then we will be saying this is a uh, contour method of border or strip irrigation method, or we have a straight regular field like rectangular field or rectangular field or square field. So that can be distinguished from each other. For example, in hilly area, when there is steep slopes, we cannot make a very good straight field throughout the irrigation area. So we divide the land into small fields of irregular shape, irregular based upon the available contours. So that place which can be brought to the same elevation, that is made a small field. Then another terrace is made, another contour field is made, another terrace is made. So that is the contour farming or terrace farming or contour based farming in that hilly area. So you will see this contour or terrace farming in hilly area, while this straight kind of farming in Punjab or in plain area, you will not see the contour farming over here. So these methods are further described, and a number of videos are available on YouTube. For example, the video described at the bottom that show through the animation some of the method of irrigations described over here. They have put a few of them which we have not mentioned over here. For example, they have also mentioned use of Persian wells. Local language में जिसको हम कहते हैं राहट, the wheels which are rotated with the help of the bull, and another wheel have a number of buckets attached to it, and because of the rotation of those wheels and the buckets, water is lifted to the upper area. So that is for us, that is a kind of the lift irrigation. So we have not mentioned it over here, but this YouTube is mentioning that one also as a method of irrigation. So you can see these videos to enhance your view, to enhance your knowledge, and because seeing a picture is better as compared to just reading. So add or use both of these resources so that your knowledge can be enhanced and you can see it. Within the surface irrigation, there are a number of methods, but what do we mean by surface irrigation? It is clear from the name. Water is supplied to the field from above the surface of the ground, not from below the surface of the ground. So surface irrigation method is that one. So very simple thing. When we supply the water from above the ground surface, so then the method will be called as a surface irrigation method. It is the oldest method of application of the water, but it is marred. It is linked with the low efficiencies. This method, as compared to the drip irrigation or subsurface irrigation, all the surface irrigation methods are having a problem that there will be a pondage of water in the top of the surface. When we apply water through the surface irrigation, there will be for some time water will be standing on the ground. So that we call as a pondage of water. So when water is standing for a longer period in the field, then evaporation losses are higher as compared to those methods which don't allow pondage of water. So that's why this method, all the methods are sub-methods of surface irrigation, results in low application efficiency as compared to the subsurface, as compared to sprinkler, as compared to drip irrigation method. But why they are popular? Their reason for popularity is they are easy to apply, they are easy to understand, they are less cost intensive. Initial cost to prepare a land for surface irrigation is less as compared to the other methods. So their application efficiency, depending upon the sub method of the surface irrigation, depending upon the sub method of surface irrigation, varies between 40 to 80%. So if we go to within the different kinds of surface irrigation, the first one is applying the water to the field without properly containing the water within the field. If we make some arrangement to contain the water within the field, what is the way to contain water within the field? Field mean a kyari, a piece of the land which is separated from the other land. So in agriculture or in irrigation, we will be saying a part of the land which is provided water uh, uh, at a certain time. So that part of water which is separated from other, so that will be called as a field. So whole farmland is divided into a number of fields. So each field need to be provided with the water. Depending upon the availability of the water, we can provide them simultaneously. We can provide water simultaneously to a number of fields, or we can give them turn by turn. We can apply water turn by turn. So when we don't provide any containment to a field and just we leave the water, we flood the area, we provide the water, and water is moving without any control in the field. So that method will be called as uncontrolled flooding. And of course, you will not like this method, and this is not the method which should be practiced when you have the shortage of water. So it should be practiced only when you have abundance of water, you don't have the utilization of the water, then this method. So this is the method of uncontrolled flooding, or sometimes they call it wild flooding, or sometimes they call it free flooding. So this method is, of course, it irrigates the area, but it irrigates the area with the low efficiencies. We don't have to prepare we don't have to prepare the field. We just leave the channel open to a field, and the water is moving with the slope in the direction of the slope to that part. Application efficiency is reduced because either deeper, if there is a pondage of water at a certain place for longer duration, one thing is high evaporation, and the second thing is high percolation. So seepage will be high, percolation will be high. So overall the losses are high, and we are getting low efficiency through this method. But this is a method should be known to you, but we should not promote this method. We should go to the better methods. So for example, the next method is controlled surface irrigation. One of that method is border or strip irrigation method. So border or strip irrigation method, we prepare a field by providing containment with the help of small with the help of small ridges created on the side of that field. so that the water should remain controlled within that field. So in this method, we make the land in the form of a strip or in the form of a border. So usually the width is smaller, length is larger, so it seems to be like a strip. If we see a picture first, for example, over here we are showing you a farmland which is divided into a number of strips. So these thick black lines are actually small buns or small ridges or small embankments created to contain water within this one strip at a time. So these ridges, side ridges and these downstream ridges, they are containing the water. So water is supplied to the strip. So name of this method is received because of the shape of this field. So they are making this field in the shape of a border or in the shape of a strip. So water is released to this strip or this border with the help of a supply channel. So a parent channel or a supply channel will be there on one side of the strip and usually at the higher elevation side of the strip. And the water is entered into the strip either by cutting the bank of that channel, cutting the bank, and this channel can be simply a water course, and this channel can be the channel within the field. So water course goes to the all farmers' land, and after the water course, the small channels have to be made by the farmer himself. We don't call those channels which are running within the field of one farmer, we don't call them as a water course, we call them as a field channels. So it can be a water course, it can be a field channel, and it can be the bank can be cut to provide water, or people can use flexible pipes which can be filled with water, and once they are filled with water and their one side end is in the parent channel and the other end is in the field, and if the level of the parent channel is higher, level of water of the parent channel is higher as compared to the outlet end of this pipe, so then water starts flowing, and we say that we are using siphon to provide water. So one method is cutting the bank and letting the water enter into the strip and then closing that bank whenever we see that the sufficient irrigation has been done, closing it physically. So that is practiced most of the time in Pakistan. But this method of siphon, providing water through siphon, so that is also practiced in the modern world. One of the video can help you understand how this siphon works. Over here in this picture, this strip is provided water from the field channel with the help of these three siphons placed over here. This is neighboring strip also have the siphon. The benefit of using siphon is you don't have to cut the bank. When you cut the bank and you refill the bank, we think that higher losses occur. We think that higher labor is required. So these are the two things. One thing is you cannot close it tightly, so it will continue to lose some water. The second thing is that it is more labor intensive. So siphon method, whenever you have the pipe available and whenever you have the sufficient head available, so it needs some suitable head available, head difference available between the parent channel water level and the water you want to provide in the field. How do it work can be well understood by the video. वो वीडियो कहाँ पे है मुझे ढूंढने दे. For use of siphon, see this video. ये slide 21 पे ये वीडियो मैंने रखी हुई है.
दवांगे ते जरा कहंदा बोतलां वा कहंदा वो एक एक दवांगे लेकिन कहंदा वो अभी ਅਸੀਂ 10% एक्स्ट्रा दवांगे.
तो कोई इसको समझाएगा गुलाम मुस्तफा को?
कहंदा बाकी शामां सारियां जिन्नी वारी मर्जी दोबारा मकान बोतलां कहंदा एक एक वारी होएगी लेकिन फिर भी कहंदा ਅਸੀਂ 10 15 यानी कि ना 150 ना 15 20 बोतलां ਵੱਧ दे देंगे अगर कोई नहीं वो एक कल छोटी बोतल देंगे फी बंदे ਨੂੰ हर बंदे ਨੂੰ ਉਹਦੇ ਸਾਹਮਣੇ ਉਹਦੇ ਚ ਫਿਰ ਆ ਹੋ ਜਾਂਦਾ ਨਾ ਕਿ ਉਹ दोबारा नहीं मांगते मंगते घट है नहीं नहीं छोटी
क्या हुआ है?
क्यों मंग रही है नहीं आंटी वड्डी वड्डी 8 बंदे बैठे 2 ने ज्यादा पा ली ते बाकी पूरे रह गए फिर वो मांग
So I have removed Mujtaba. Ask him to talk to me. CR of I don't know which section Mujtaba is in. Mujtaba का section कौन सा है? CR. और सारे चुप क्यों हो जाते हो?
सर डी सेक्शन है।
डी सेक्शन है। उसे कह देना मुझसे बात करे क्लास के बाद। कैसा बच्चा है? शरारती बच्चा है, शरीफ बंदा है?
सर शरीफ बंदा है सर।
शरीफ बंदा है, दुकान पे बैठा, दुकान पे बैठा है। ओके, मैं क्या करूं, मैं कहाँ पे? देखो डिस्टर्ब कर दिया ना शहजादे ने। मुझे इसका मसला नहीं है कि दुकान पे बैठा है, मुझे ये मसला है कि वो पढ़ नहीं रहा, कम से कम पढ़ नहीं रहा, इतना श्योर है। ओके, कंट्रोल वी। So have you seen how the siphon start working? कोई बताएगा कैसे काम किया इसने? Just by this I repeat, मैं repeat करता हूँ एक बार फिर। So who will describe it?
Yes, sir. She uses the same principle as we use in case of a hand pump. So he developed a pressure inside a siphon.
In case of hand pump.
Yes,
hand
sir.
pump lift the water. Hand pump lift the water. No. Hand
So
pump
actually,
have a unidirectional valve.
yes, sir.
Hand pump has a unidirectional valve. By pump action, by moving it up and down, it goes down and then lift it physically. But yes, below that valve, it causes suction. Below that valve, yes, it causes suction. So what she is doing, an empty pipe, she push it into the water while its end is downstream end is open. She push it into the water, downstream end is open, which is in her hand. So that was open when she was pushing it. When she is pulling it back, she close it. So the water which entered into the pipe, that remain within the pipe. Then again she push it and remove her hand. So more water enters into it. So after 2 or 3 times, the whole pipe is filled with the water, and then she leave that water at the downstream side at the lower elevation. So the inlet opening is at higher elevation, or it can be at lower elevation. The water level in the water course is at higher elevation. The downstream end is at the lower elevation. So once the pipe is full and there is a head difference, so then water starts moving through it. And it is moving through a higher elevation. The bank is higher. So that is a principle of a siphon, principle of inverted U-shaped pipe that people also utilize to get petrol from a friend's bike also. अगर उसके टैंकी में से पानी निकालने के लिए. So siphon can be utilized, and you can see such videos further, and this can be practiced for supplying water to the strip, supplying water to the furrow. Over here they are showing the furrows supplied with the siphons. So ये वाली यहाँ पे तो siphon इसने लगाई ही नहीं है, तो इसको मैं यहाँ से हटा के जहाँ siphon लगी हुई है, for example over here, यहाँ मैं ये लगाऊंगा तो ये नजर नहीं आएगी. चलो, for use of siphon. So coming back to the strip irrigation method, name is taken from the shape. Its width varies from 3 to 20 meters, and length varies from 100 to 400 meter depending upon 2-3 factors. The size of the strip depends upon 2-3 factors. One is soil type. More porous is the soil, smaller should be the size of the strip. Because if more porous is the soil and we make a larger strip, more percolation losses are expected. So we should supply for more porous soil, we should make smaller. Second thing is depending upon the size of the supply ditch, supply channel. अगर वो छोटी है supply channel, तो smaller feed should be utilized. Third thing is how much water we need to apply. So depending upon huge water application, the size varies. So, and second thing is, so these a suitable slope is required in case of strip method, and as compared to the second method which we call as check method. In check method also we supply water to the field, but the field which is contained within the ridges is smaller as compared to the strip, and it is more square shapes, not perfectly square, but it is the width to length ratio is not very high. The length to width ratio is not much high, so it is close to a square shape, and usually it is smaller. So when we have slope in across the field direction, hopefully you are seeing the mouse movement. If you have a slope across the field, so then dividing into strips and making one strip leveled in the transverse direction and having slope in the longitudinal direction. So if that is the condition of slope, then this strip method is better. For example, I repeat it, if you have a high slope in transverse direction, then divide it into strips so that one strip should have more or less leveled ground across the strip. It can have a slope along the strip, but across the strip it should be leveled. So for that, strip method can help us better if we have considerable slope in the transverse direction. If the whole of this field was leveled in transverse direction, we could have make it as a check box. We can make it as a square box. Then this method would be called as a check method or the basin method. So जहाँ पे इस तरह से slope हो transverse direction में, तो बेहतर है उसको divide कर दें into leveled ground, into level strips. Strip do have a slope in one direction, but in other direction, in transverse direction, it should have zero slope. So that will be better in application of water. Otherwise, if you make this whole as one field, and it has a slope in both the direction, in transverse direction and in longitudinal direction also, then if you apply water from the one end, the top end of that place, then water will not be supplied in a better way to all the places. Better way is that way in which the water is supplied to all the corners in an even way. Thus, more or less similar depth of water is reaching to all the places. So if it is leveled in across the direction and have slope in one direction, then we expect that we can give water distribution evenly. We can apply water evenly to the whole land. Then the next strip will be irrigated, then next strip will be irrigated. So these things we have to keep in mind which method we want to use. So it depends upon the slope of the land also. So it should have a suitable slope in longitudinal direction. And that varies between 0.2 to 0.4%. That is considered suitable, but people have practiced this for slopes out of this range, that is 0.12. 8% slope also people practice it, but this slope is in the longitudinal direction. In the across direction, the strip should be leveled. The ground within one strip should be leveled. It should not have cross slope. So these are the things which you should keep in mind. Other thing is that it is suitable for those soils which have moderately low to moderately high infiltration rates or intake rates. It has been said that for those soils which have high porosity, high intake rates, for that method, the drip and sprinkler method will work better. So if it has moderate intakes level are there, then we say that this method of border strip is suitable. This method is suitable for all the crops except some delicate crops, except those which require prolonged flooding, except those crops which require prolonged flooding. For example, if we need to apply water for, we want that water should be kept ponded over here for a few days. So prolonged flooding, for example, that is required in case of rice. So then this method is not suitable. Then better is make the whole field as a level field and apply the check basin method and keep the water standing over there and then use that method. This method, however, requires preparation. As compared to the uncontrolled flooding, this method need, of course, preparation of the land, leveling of the ground, making the ridges. So it needs labor and the initial cost for preparation of the ground. So how water is supplied, that is mentioned over here, that I have already described. So this is the larger size of the same figure. It contains a supply ditch. It contains strips. The whole field is divided into strips. Longitudinal direction should have a uniform slope. Across direction there should be no slope. So that is the actual application of water. This figure has been taken from the Food and Agriculture Organization report. Second method of surface irrigation is called check/basin method, check or basin method. This method is based on application of the irrigation water to a level or nearly leveled area. So it don't have a slope within a check, within a basin. We don't have slope in longitudinal direction or cross direction. So you can see this method. This is frequently used for rice. This is used for orchards also. For example, over here, one of the tree is planted within a basin. So on the all sides, we have made a ridge, and this basin size is so much that water will keep standing over here for a longer period, and this plant will be getting a sufficient quantity of water from this check basin. So this same field can be cultivated with crops also, and water will be kept standing in it for a longer period. So if we have a leveled ground across the direction or in longitudinal direction, both direction we have level ground or nearly level ground, then we use this check basin method. Entire field, the whole field is divided into a number of leveled plots or kyaris surrounded by levees or ridges. Water is admitted from the farmer water course to these plots turn by turn. Application वैसे ही आप you can apply water to each of them turn by turn, or you can open the bank for a number of the for a number of basins. This method is suitable for a wide range of soils ranging from very permeable to heavy soil. Heavy soil किसको कहते हैं? Those soils which are containing more quantity of clay. So those soils are considered as the heavy soil. So their permeability is low. The farmer has very good control over the distribution of the water. So its efficiency, because of the loss of water through deep percolation and the surface runoff can be minimized and adequate irrigation of the entire farm can be achieved. Thus, application efficiency is higher for this method as compared to method of uncontrolled irrigation. So its efficiency is considered better. However, this method requires constant attendance and work. because the whole field is divided into the smaller smaller basin or smaller check box. So then more vigilance is required from the farmer. He has to close it, open it, close it, open it. So as compared to the strip irrigation method, the vigilance and the attention of the farmer is required in a better way. So besides, there is more loss of cultivable land. Why we are saying there more loss of cultivable land? Because there are more ridges available, more embankments are there. So higher quantity of land is lost to the ridges or levees. Levees are using more space. So sometimes levees are made sufficiently wide so that some row crops can. So it causes loss of the land because of making of the ridges. But depending upon the slope, sometimes checkbox is necessary and we have to go for that. And depending upon the slope, strip method can be utilized. If we have cross slope, then we don't have other option but to go to the strip method. So this is the checkbox, a check basin method, which is utilized to irrigate a land. Main parent channel, and then within the field ditches are over here. So this is the ditch within the field. So it can supply water to each check or each basin. So it can supply water over here. It can supply water over here. So this is a field channel, field ditch. So we need field ditch between two checkbox rows so that each can be supplied independently. The method is frequently used to irrigate orchards and for rice crops where conditions are favorable. Two or more trees can be included in one basin. So some guidelines for selecting the size of these basin or size of these strips. For example, the width of the strip should be limited with respect to the longitudinal slope. If the longitudinal slope is, for example, 1%, it is recommended that the width of the strip should be on average between 15 to 25 meter, not out of this range. If slope is less, then we can go for a larger width strip. If slope is higher, then we should reduce the width of the strip. How much area should be covered in a strip or in a basin, that is mentioned over here in the right hand side. Depending upon the size of the field channel, how much water is coming to that channel. 1 cubic channel is there, or half cubic channel is there, or larger channel is there. Depending upon the type of the soil. If it is, for example, sandy loam is there. Loam is a kind of soil. Loam is a kind of soil which have all types of soil sizes within it. Clay is there, silt is there, sand is there. So this a mixture of silt, sand, and clay. So that is usually called as the loamy soil or loam soil. So this sandy loam is having small quantity of clays, having small quantity of silt, and more quantity of sand. So that is sandy loam. So if sandy loam is there, then and 1 cubic channel is providing water, so suitable size of the strip or basin will be 600 meters square. So from this table we can get some help to decide the width of the strip, and from here we can decide the size of the strip. Second method of surface irrigation, third method, rather fourth, last method of surface irrigation is the furrow method. Furrows is the name given to the small channels. Furrow is nothing but small channels having continuous and almost uniform slope in the direction of irrigation. In longitudinal direction, it will have small slope, but because this is a small channel, so there is no concept of the cross slope. It is not like a strip. If we reduce the width of the strip, we will make it like a furrow. So furrow ban jayegi. In strip method, we make the ridges above the ground, while in furrow method we make a channel in the ground. So construction is different. Strip is made in a different way. Furrow is made in a different way. But furrow width is very narrow, 1 feet, 2 feet, and then as ridges there, then another furrow, then another furrow, and you have seen the picture, so that you can well understand how the furrow looks like. Special kind of plows or cultivators are there. They are attached to the tractor and then they make the furrow quite easily. Their shape is such that they make the channel, and the earth which is excavated, that is placed on the ridges at the between two channels, that is placed over here. The crop is grown, usually the row crops are grown on the ridges, and they are planted on the ridges, and water is supplied to the channel. Benefit of this method we get from the fact that not the whole field is underwater. If you see the whole field, not all of the land is underwater. In this figure, we can see that about 50% of the land is not with the ponded water, while 50% of the land is dry, 50% of the land is wet. The crop which is grown on the ridge, its roots gets the water from the channel through seepage or through capillary action. So water reaches to the roots through capillary action. So it gets sufficient amount of water. And these channels or these furrows can be utilized to move the tractor through this field for spray of the fertilizer, for removing the weeds from these channels. So these can be used for that purpose also. So because of the fact that not whole field is underwater, the evaporation losses are quite less. So that make this method as one of the efficient method out of all the surface irrigation method. So its efficiency goes as high as 70% as compared to the other methods. So it is comparable to the efficiency of the sprinkler method and our subsurface irrigation method. So what are the salient feature of this method? We make the channels which are called as the furrows, and water infiltrates through the wetted perimeter of the furrow. Furrow are used to irrigate the crops planted in the row, जिनको हम row crops कहते हैं. It can be used for cotton. It can be used for what we say. Sometimes I think maize can be grown, sugar cane can be grown. It cannot be used for those crops which need standing water for longer duration, like rice के लिए हम use नहीं करते. It is not used even for the wheat also, which we don't grow in a row. We just spread the seed, and they grow on the whole field on an evenly basis. So of course we are losing some of the land to this channel, so only the ridges are used. So when we want to grow the crops on very near on high density basis, close to each other, then this method is not utilized. So rice and wheat, we don't use this one. So we use the cotton and maize, and other vegetables are sometimes grown on these furrows. Its benefit is that it is better efficiency. Application efficiency is quite better. Problem with this method is, of course, we need more labor as compared to the strip irrigation, as compared to the check basin method. We need more labor to make these channels. High energy is required to make these channels. So furrow necessitates the wetting of only about half to 1/5 of the field surface. अब कौन तंग कर रहा है मुझे? शहजादे किसने ज्वाइन किया? 205. You have just joined and your mic is on. Your mic is unmuted. शुक्रिया तुम्हारा. कहाँ से तुम आ गए हो?
Sir, I had internet problem just for 5 minutes.
Internet problem. Keep your settings such that when you join the meeting, your mic is automatically muted. तो इसकी setting होगी, देख लो, check कर लो. Okay. So furrow provide better on-farm water management capabilities for most of the surface irrigation condition and variable and for several topographical conditions. So out of the surface irrigation method, this is the best method we have available with us. The following are the disadvantages. There are some disadvantages for furrow irrigation. One is the possibility of increased salinity. How can be salinity enhanced in furrow method? We are applying water to the strip irrigation. We did not say that any high salinity will be there. The reason for this mentioning that there is a possibility of increased salinity is that some water evaporates from the ridges also. Although we have not applied water over there, but that ridges will also get some seepage. So some water will be evaporated from there. So when water evaporates, the dissolved salts remain. All the water have the dissolved salts in it. Even the drinking water you are drinking, it has some quantity of the dissolved salts, which are required for our nutrition, for our health also. It should not be more than the allowable limits. Similarly, the water which we supply to the field, to the agriculture irrigation, they have the dissolved salts within it. We are not talking about the suspended sediments. We are talking about the salts like sodium chloride, like calcium chloride, so which we don't see, but those are dissolved within. So when that water evaporates, we see their presence in the form of the fluorescence, in the form of the whitish material on the ground. So ridges are not supplied with water, but they have some evaporation of the seeped water. So ridges contain some salts within it. So same salts will be there in the channel also. But because channel get sufficient quantity of water, and that water percolates also into the field, into the deeper grounds. So those salts are dissolved within that percolated water and goes to the deep layers. While in ridges, we don't have sufficient quantity of water. Some quantity of water is available, but that evaporate. So salt remain within the ridges. While in the channels, salt goes to the deep layers, and the top layer is having less salinity as compared to the ridges. In ridges, after few years of application of the furrow irrigation, if we don't remove those ridges, then ridges will be having higher salinity as compared to the channels placed in the channel. So that is one of the problem with this. So after few year, or after every year, you have to make that ridges mix with the channel condition, and you have to make these furrows again. So that the salinity should be well mixed within the whole ground. Loss of water at the downstream end. If the channel don't have the control on the downstream side, then we can lose some water. Necessity of extra tillage work. So that we have already talked to you. It is more labor intensive. Tillage mean plowing. Tillage mean preparation of the land with the help of the plows. So it needs high labor, or high extra tillage is required. Possibility of increased erosion is there because ridges remain more or less dry. So wind can cause more erosion. So that is possible. So these are small problems which we should be knowing. Furrow irrigation requires more labor than any other surface irrigation method. So here is the guideline which can tell you how much should be the length of a furrow if you have a certain slope in the field. If, for example, if you have 1% slope, and if you have the loamy soil, and if you want to apply 10 centimeter of the water, so 300 meter is the suitable length of the furrow. If loamy soil is there and you are applying about 10 centimeter, 4 inches of water you want to apply to the land, and you have a slope of 1%, so 300 meter is recommended. So this table can help you decide type of the length of the furrow channel. So I take a 5-minute break over here. After the break, I will start this subsurface irrigation and the sprinkler and the drip. We will be trying to finish this in today's lecture. So any questions what we have studied till now? You are welcome. Okay, I stop the recording so that the video should be small, and